So let's talk about these guys on the inside. All right, let's take a look at this first one. We have a function here where h of x equals 1/2 x plus 2 x minus 4. Okay? The first thing you need to ask yourself is, what are the intercepts? What are they? Anybody know? -2 and 0. And 4 and 0. Vertex, okay? If we go ahead and use that information, plug it into the equation of the vertex, right, which was m plus n over 2. So it'll be -2 plus 4. Let me look back to our front to see, just to confirm we're doing that right. Yep, right here. Okay, so m plus 2. So sorry, not the vertex. Hold on. The vertex would be plugging in. Let's find the axisymmetry first. So m plus n. So if we go back to here, right? So we're going to have x equals -2 plus 4 over 2. Huh? Yeah. Axis of symmetry. I'm going to find the axis of symmetry before I can find the vertex.
Yes, at this time, if we...
All right, so what that is x equals -2 plus 4 over 2, okay? X equals -2 plus 4 over 2. Okay? We plug all that in. -2 plus 4 is going to give me +2. 2 over 2 is going to give me x equals 1. If we take 1 to find the vertex, which means we just plug it back into here, okay? We get 2 times -4, which gives me, 1 plus 2 is 3. 1 minus 4 is going to give me 3, so -3. So 3 times 3 is going to give me 9. Half of 9 is 4.5. -4.5. So my vertex is going to be 1, -4.5. Axisymmetry is x equals -2 plus 4 over 2. Solve that, we get x equals 1. Okay? So, let's graph some things real quick. We know that the axisymmetry's got to be at that halfway spot, right? Or, sorry, axisymmetry is at -1, so he is right here. We also know the intercepts are at -2. Here, we can do AOS equals 1. We know that the intercepts are at -2. We know the other intercept is at 4. Looking good. We know the vertex is at 4.5 at +1, -4.5. So somewhere, let's call it right there. Okay? So we can call this 2, -4 as a point, and we can do, we're going to find out that the y-intercept is at -4. So it looks like my parabolic shape is doing this number. Okay? So doing that. Okay? The y-intercept would be 0, -4. It opens up, so it's a positive a, which means that if it's as far as a max or min, it is a minimum. The value that tells you that is the -4.5. The domain would be negative infinity to positive infinity, aka, or all real numbers. And the range would be from negative 4.5 to positive infinity. Right? Now, let's talk about how I found that. For the vertex, y equals 1/2, 1 plus 2, 1 minus 4. There's a minus in there, sorry. And I don't have my whiteout out here. I gotta get my whiteout. Okay, so it would be 1 minus 4. There we go. Okay, we do that, we get that y equals 1/2, 3 times negative 3. I then get that 1/2 times negative 9. So y equals negative 9 over 2, which reduces down to y equal negative 4.5. Okay, and for my other one, which is my y-intercept, okay, remember we find y-intercepts by plugging in 0 for all my x's, so 1/2 0 plus 2 times 0 minus 4, I get 1/2 2 times negative 4, I then get 1/2 negative 8, and I get y equals negative 4. Okay? Look at the other one. So looking at the other one, we have f of x equals negative 2x minus 3x plus 1. So my intercepts are going to be 3, 0, and negative 1, 0. Again, the best way to think about that is just take the terms in there. Another way you can find intercepts is set this equal to 0 and solve for the x. Okay? Does everyone understand what I mean by that? No? Okay, so what do I mean by that is this. Okay? So if I set this whole thing equal to 0, okay, I have two possible answers. Think back to quadratics and the quadratic equation. This is why you have two possible answers with these guys. So negative 2 equals 0, throw it out, don't need to worry about it. If I divide this whole thing by negative 2, the 0 is going to get rid of it. 0 divided by any number is 0. So all you're going to be left with is x minus 3 and x plus 1 equals 0. You're going to split that up. You're going to have x minus 3 equals 0. You're going to have x plus 1 equals 0. If I add 3 to this side and subtract 1s from this side, I end up with these guys. Yep. So if I set this equal to 0, all right, and I solve for 0, which means I'm going to divide by negative 2 because negative 2 is just going to get rid of them. Okay, because if I have 0 divided by any number is 0. I then get x minus 3 and x plus 1 equals 0. I then split this apart because I have two possible answers and give me 0. I can either plug in negative 3 or positive 1 when I'm done because I solved for it and I got 3 and 1 down here. If I plug them back in, there's the thing. 3 minus 3 is 0. 3 plus 1 is 4. What's 4 times 0? 0. Checks out. So any of those two coordinate values that I plug back in will work. Okay? All right. Now, for vertex, again, remember the vertex equation, right? Back to the front here. Stated, it was m plus n over 2. Sorry, that's axisymmetry. For vertex, we need to find, I keep mixing them up because they wrote it backwards in this table here. They did these backwards. I would have done axisymmetry first, then vertex. For vertex, we need to find axisymmetry first. So for the axis of symmetry, right, we're going to have x equals 3 minus 1, all divided by 2. and I get that x equals 1. If I take that vertex and plug them back in, take that x symmetry, sorry, and plug them back in, so I've got the same axis symmetry as before. Okay. So we plug all our values in. So we come back over here to our handy dandy table. We're going to find our vertex. We plug in the axis symmetry, the x value, to find the y value. So if we plug in 1 into this guy, we have 1 minus 3, which is negative 2, and we have 1 plus 1, which is 2. Negative 2 times 2 is negative 4, times negative 2 is going to give me positive 8. So the vertex is 1, 8. Ooh, way up there. So he is all the way up here. Okay. The y-intercept, again, to find y-intercept, look back to your table. Y-intercept says we got to plug in 0 for x. Okay. Plug in 0 for x. This goes negative 3. This goes positive 1. That's going to give me just negative 3 times 2 is going to give me positive 6. Negative times negative. Close though. Positive 6. So I get 0, 6. Go over here and graph it. He's right there. Now, while you're there, mirror it. Remember how we used to do reflections? Count 1 to the axis symmetry, count the other side, done. Positive 6 and 2 positive 2 positive 2, positive 6. So that's why we talked about transformations so much. It came back to haunt you. So intercept is positive 6. Mirror it because it's reflecting, so over the axis of symmetry. That's what symmetry is. So count to the other side. 1 difference from here, so come to here, count 1 to the right, dot it. This right here is positive 2, positive 6. Might as well get it while we're there. Make our lives easy. As we graph things on the left, throw it on the right. Don't just willy-nilly it. Okay? You look this in a graph table, and I'll show you guys that here in a second when we do independent. All right? Tables will show you literally where to plot these. Okay? Next up, it opens which way? Up or down? Down. So it's down like a crown, which means it's negative. If it opens like a cup, it's positive. That's how I used to remember. Okay? So it's down. Which means A is negative, and sure as heck it is. Negative 2. Fantastic. So, is it a max or a min? Max, right. Okay? And the value is 8. Maximum value is up here. The domain is what? Negative infinity to infinity. Answer soon enough. Or all real numbers. And the range is negative infinity to 8 included. You will always have, for as far as you're concerned, included. I know it looks kind of messy, but that is 8 with a bracket. Back here, I'll rewrite it. There we go. That's better. Okay. So, in terms of how we found that stuff mathematically, just to round it out. Okay. So, well, first we should plot our points. So we've got intercept right here, and we've got an intercept right here. Okay. And let's just graph this sucker. There we go. It's a little lopsided, apologies, but you get the idea. Okay. Now, in terms of the math behind that, for the vertex, we have y equals negative 2 times 1 minus 3 times 1 plus 1. So then we get negative 2 times negative 2 times 2. We get negative 2 times negative 4. So y equals 8. And for our y, we had y equals 2 times, negative 2. I botched that. Y equals negative 2 times 0 minus 3, 0 plus 1. We get negative 2, negative 3, positive 1. So we get negative 2, negative 3. Therefore, y equals 6.